Everyone, today we're going to be looking at estimating probabilities, right? And so what we're talking about here is this idea of experimental probability and how that can actually change depending on if something is fair or not fair, right? And so when we talk about probability, a lot of the time we're looking at theoretical, okay? But there are things that we don't take into consideration. And so we run experiments and then estimate based on those. So when it comes to experimental probability, we still calculate this probability the same way that we would a normal one, but we run our trials and then we take the number of times an event occurs and divide it by the number of trials to give us a probability. And so through all our experimentation, our probabilities should still add up to 1. So, for example, we have these two girls who are throwing a drawing pin, right? And they're just trying to see if it lands point up. Catcher decides to toss it 50 times, and she counts the number of favourable outcomes, so the probability of it landing up being 33. Mickey repeats the experiment, but she tosses it 100 times and then ends up counting 62 favourable outcomes. So, Hatcher's estimate of it landing point up, based on her experimentation, is going to be that 33 out of 50. Okay, if you can simplify it, you do. Okay. Mickey's estimate is going to be a bit different because she ran more trials, and hers ends up being 62 over 100, which is 31 out of 50. And so the expectation here is that if, let's say, we were to run 200 trials, that it would be a bit closer to the actual probability theoretically. Now, when it comes to experimental versus theoretical, we usually have a preferred estimate, and that is the more the merrier, right? And so in this case, we would prefer to use Mickey's estimate because she ran more trials. Okay, so the more trials, the more accurate your probability is going to be. Now, feel free to pause here, but this one is more about if we were to draw up a situation, what we would expect from it. So we are using more theoretical here, but we have a square dartboard that consists of a red square drawn inside a larger white square, which has side lengths 12 centimetres. So my current dartboard is at 12 by 12, and our red is evenly spaced 2 centimetres from that 12 centimetre edge, right? And so this is a really dodgy drawing, but we've got our red and we've got our white, okay? And so if we're assuming that the dart thrown at the board has an equal chance of landing anywhere on the board, and we want to find the probability of the red area, we're going to be doing our red divided by our white. So in this case, that red is going to be 8 by 8, being 64, and the white is going to be 144, which is going to simplify down to 16 over 31. So even though it doesn't look like it, there is about or just over half a chance of landing in the red versus the white.